I'm live. Yay. This is Math 75, mathematical analysis for business and economics. We're in 1.1 and we're talking about break-even points. Woohoo! So in English, if you think about the phrase break even, to break even means you don't make any money, you don't lose any money. That's my quote right there. So, what does that mean? Well, the easiest way to say this mathematically is, in other words, your profit, the extra money you get to keep, is zero. Now, since profit equals revenue minus cost, if the profit is zero, it must be that the revenue and the cost canceled each other out, which means the revenue must equal the cost. So, in other words, you've sold enough of whatever you're selling. And in our class, we said it was burritos. So, we've sold enough burritos so that the money we've made allowed us to pay off our bills, all of them, but we don't get to keep any extra money. Now, here people get worried. They're like, uh-oh, if I'm at a break-even point, then I'm going to starve because I'm not making any money. And the answer is no, because usually your costs include wages for everyone. Hopefully you're paying yourself as well. So everyone's getting paid, and that's part of costs. We don't usually put it into our equations because it's a little more complicated, but in the wider world of business, costs will include all the money you're paying to the managers and to the individual laborers and to the I was thinking administration, that's for a school, but for the management and like the CEO and the COO and all those wonderful people. Everyone's getting paid. So, what is profit? Well, profit is the extra money that can be put back into the company, say to buy, I don't know, a bigger kitchen or to pay for more machines to make tortillas or whatever it is we want to do. We can expand our business using profit. If we're at zero profit, it means that we're meeting all of our bills and everything is great. We just can't get any bigger. So, a lot of times companies will ask, where's our break even point? Because that's the point where you have to get to pay off all of the costs associated with the business. So, let's take a look at this. I'm going to tell you that the fixed costs are $30. The variable costs are $5 per unit. In this case, it's burritos. And each unit can be sold for $7. So these are $7 burritos. So already, if you think about it, if we're selling them for $7 and they cost us $5 each, we're making an extra $2 per burrito. Now we have fixed costs of $30. So you could imagine if we know each burrito is going to give us $2, we could figure out how many we have to sell to get to $30. But no spoilers. Let me show you how to set this up. So we're going to have to go back to chapter 0 in our minds. So the Wayback Machine. We got to remember chapter 0. Revenue is price times output, which in this case, the price, I need my handy dandy, the price, each unit can be sold for $7. So that's our price right here. So our price is going to be $7. And if you remember, output is generally going to be X. You could use another variable, but generally it's going to be X in this book. Now, cost is broken down into variable cost and fixed cost. And honestly, this can be singular or plural. So let's take a look. I've got fixed costs, very straightforward. It just says fixed costs are $30. So that's going to go right there. So my cost is going to be equal to, and that's going to be 30. And then my variable cost, I need one more. And it says something really interesting. It doesn't just say $5. It says $5. And I don't know if you can see it right here. I'm going to write it up above. $5 per unit. So that is a little reminder that we don't just put 5 here, we do 5x. And again, the word variable is also going to tell us, oh, variable, we need a variable in there. This part should change. As we make more, this cost goes up, right? It's $5 for one, but $10 for two, $15 for three, etc. So if I have the revenue right there and I have the cost right there, if we want to be at a break-even point, which some people call the BE, we want revenue to equal cost. So 7x equals 5x plus 30. So then I'm going to draw a straight line across here to kind of separate right along there. So visually separate everything. I'm going to subtract 5x from both sides. I get 2x on the left and 30 on the right. If I have 2x on the left and 30 on the right, I'm going to divide by 2 on both sides and get x equals 15. 15 in this case is units, but we're talking about burritos, so I'll call it burritos. So if I sell 15 units, that will make just enough money so that we pay off all the variable costs, because you need to pay those off, but we also pay off the fixed cost. So we've made enough money that nobody has any extra money and nobody owes any money. Woohoo! So part B is going to ask a slightly different question. If instead of breaking even, the company wants to ensure that the revenue is greater than the cost, so in other words, I want to make sure R is greater than C, how would you solve it? Let's graph the solution. Okay. Now, it could be that you could look at this and right off the bat know this answer, but I'm going to go ahead and solve this separately because, just in case you're like, I'm not too sure. So what we can do is we take the revenue, which we already know is 7x. That's supposed to be greater than 5x plus 30. And then what? Well, we do a lot of the same work. I'm going to subtract 5x from both sides. Woohoo! Yay! And I get 2x must be greater than 30. So if 2x is greater than 30, I can divide both sides by 2, totally legal. And I get x has to be greater than 15 units. Now, a lot of you already knew this because you saw this answer and you're like, oh, well, that's just going to be the answer. So, but we need to sell more than 15 burritos or units. Unit is the word we use to mean the things we sell. And what does the graph mean? A graph look like? Well, again, for me, I'd like you to find 0 and then 15. It can really be anywhere you want. And then it's a strictly greater than. So either I'm going to start with a parenthesis or I'm going to start with an open circle. Woohoo. Okay, there we go. Break-even points. Yay! Now what's up next? Now this is the problem that will haunt you, because not just that it might haunt you in your personal life, but this problem, we will keep working on this problem over and over again till it starts to make sense. And the reason for that is that this problem will become some of your careers. One of the things you can do with a business degree is you can choose to go into accounting. If you do go into accounting, part of the job is that you start taking tests. You have to get certified to do different things. For example, a lot of people have heard of a CPA, a certified public accountant. Some other tests you can take could get you into financial planning, for example. And this is a very simple example of what financial planning can look like. One safe investment pays 5% per year, and a riskier investment pays 12% per year. Okay, so we got two investments. Now, this is obviously a very simple situation because when you think about the world, how many investments are there? There are so many investments. I don't even know if anyone's actually counted all of them. So many opportunities, including maybe your cousin who'd like to borrow some money and try to build a rocket ship, or, all the different kinds of things you can do to invest money and try to increase how much money you have. We're just picking two of them. There's a 5% investment and a 12% investment. And so a woman comes to you, you're a financial planner, and says, I have almost 250,000. I have $245,600 and she'd like to invest it. She wants to have an income of $20,000 per year from her investments. So now what the heck does that mean? Well, basically it means she wants to put this money, some people call it the nest egg. She wants to put in this principal, $245,600, and let it earn interest. And then what she wants to do is just spend the interest so that every year it earns more interest. Now, if you spend part of this, if you spend the interest plus a little bit, the next year you won't earn as much interest. So your investment will actually shrink. And then there is something more complicated than this. As a financial planner, you're going to have to tell her, well, if you invest this and you spend all of your interest, and you take it all out, all the interest out, that's fine. You will get $20,000 per year. Awesome. But after 10 or 15 years, 20,000 won't be worth as much. And so you as a financial planner will have to go a little bit beyond this problem and explain, okay, so for cost of living increases, like that there will be inflation, you may actually want to make another plan. In this class, we won't be able to model that situation. We're going to be able to model this exactly like this. So this is kind of like the starter problem. So let's go ahead and figure it out. You'll hopefully it sounds familiar. This is the problem we did in chapter 0, except now we have an income of 20,000. We've got the total. We know all the numbers. So I'm going to set this up, and you don't have to do a chart. I'm going to do a chart. Totally up to you whether you do a chart or not. Chart is your choice. I'll remind you that in the corner, you're either going to put a smiley face or maybe a dollar sign, or just scratch it out, put a little sticker, whatever you want. We don't use the little corner. I've got the 5% investment. And I've got the 12% investment. And then I've got the total. And then I'll remind you that we're still, as we're talking about this, we haven't gotten into compound interest at all. In fact, we're not going to talk about compound interest until chapter 6, many chapters from now. So for right now, we've still got the formula that says interest is principal times rate times time. So very simple, one part. So I'm going to put my principal here, my interest rate here, my time here, and my interest. So I'm going to multiply these. So P times R times T will give us the I. So does it say anything about the principal? Well, it says that the woman has a total of 245,600. So 240, oops, I already, $245,600. My hand got excited, tried to get through too fast. Okay, so we know nothing else. So now we need a variable. I'm going to go ahead and use X. Now here's the thing. Some of you who have studied these kind of problems before, you may know how to set it up with an X and a Y, in which case go for it. If you know how to do that, go for it. That's fine. I'm not going to do the X and the Y. I'm going to do this one as $245,600 minus X, just like the one we did in chapter 0. So if this is the total and X is how much we invest here, then I'm going to do 245,600 minus X for the other amount. Remember that interest rates have to be in decimal form. So instead of 5%, it'll be 0.05. Instead of 12%, it'll be 0.12. And then again, the total interest, it would be interesting. We could totally study it. But for what we're doing, this will take too much time and we don't need to. So I'm going to leave it there. Now, time. Time is tricksy. Time is always tricksy. You know, time for humans is a really interesting thing. I'm going to point out that right here, we've got the words per year. Per year tell me that we're doing 1 year. So it's 1 year for each of them. Okay. Now for interest, I've got, let's see, I used this, the $245,600 right here. Okay. And then I used the 5% is right here. And I used the 12% right here. Do I have any other numbers? And the answer is I totally do. I've got this $20,000. Now, here's the thing. Economics tends to write word problems that will make you cry. I remember during my degree, I cried a lot. I was very frustrated with a lot of the word problems. And so just because there's an extra number does not mean we actually need to use it. So keep that in mind. However, if there is a spare number and you haven't used it yet, you might want to think about what it could be, what information it's telling you. So it's telling me she wants to have an income of $20,000 per year from her investments. Oh, the total interest needs to be $20,000. That's what that's telling us. She needs $20,000 a year to live on. That's what she wants. And again, we don't have a way to do inflation in this. So she's just going to get $20,000 a year for the rest of her life. And that's assuming these two investments hold out. So hopefully they are long-term investments. And we will just, afterwards we'll say, hey, by the way, you may want to rethink some of this because $20,000 today sounds like a good thing, but in 10 or 20 years, it's not going to pay for as much. To put it in perspective, right now, as I'm recording this video, my daughter is going to one of the Cal State schools, and her total, I'm trying to think of her tuition is, I think, around $7,000 a year, $7,000 or $8,000 a year tuition to go to Cal State. When I was in college, just around 30 years ago, my very first semester, it cost under $800 per semester to go to college, to go to UC Berkeley. So only around $1,500 tuition to go to UC Berkeley in the 80s. And now 30 years later, it's $7,000 or $8,000 for 2 semesters. So what is inflation? Inflation is what happens when how much it costs in the old days is going to be a lot less than what it costs now. So again, $20,000 now seems like a great idea, but down the road, it's possibly not going to pay for everything. So as a financial planner, you do have to warn them about this, but you'll have lots of time to learn this. Okay, so back to the problem. I know I got distracted. So what do? I've got 2 empty spaces. So that's the great thing about the chart is you can look and say, empty spaces. What do I do with empty spaces? Well, the way we set this up, this is all multiplication. So we're just going to multiply across. So this is x times 0.05 times 1, which I think is going to give me 0.05x. Very straightforward. Now this little box is going to be too small because I got this nasty thing happening here. So I got 245,600 minus x times 0.12 times 1. So that's going to give me, if I move stuff around, 0.12 times the quantity, 245,600 minus x. Oh, I fit it in. But that is teeny tiny. However, this is our completed chart. Yay, we got a completed chart. That's very exciting. Okay, so what I'm going to do is I'm going to look at this last column. This is the 5% investment. This is the 12% investment. She only has 2 investments. So these 2 together should give me the 20,000. So I'm going to come down here. I'm going to add down and I'm going to write the answer right over here. the 0.05x, that's the first investment, plus 0.12 times the hideous beast, which I did it again. I tried to make it 250, 245,600. There we go. 245,600 minus x. That's the second. And that's going to give us our total of $20,000. Okay. So first question people ask me, if they can get to this point without the chart, is that okay? It's absolutely fine. If you can write this out, which after you practice this a bit, writing this equation gets a lot easier. If you can write this without the chart, awesome, do it. If you like the chart and it helps you, awesome, do it. If there's another way you do it and you'd like to do it that way, other than asking your friend Bob, who already passed this class, because that's not so good. That's not helpful for you to learn it. But if you've got another method, just show me. Say, hey, can I do it this way? And more often than not, I'll say, oh yeah, that seems great. In fact, I'm going to show everybody how to do it that way. Okay, so first step I'm going to do is I have to multiply through. So I'm going to leave the 0.05x, and then I'm going to go ahead and multiply this. And I don't know how to do this in my head, so I am going to multiply this out. So 0.12 times 245,600. So this is going to be 29,472. 29,472 minus 0.12x. And the reason it's a minus is because of that minus right there. And that equals $20,000. Okay, so far so good. Next step, I can combine the x terms. So I'm going to have 29,472 minus 0.07x. 5%, 12%, what's the difference? 7%. Okay. So let's look at this line, and I'm going to keep telling you throughout the class. Oh, look, Godzilla is peeking. Hello, I'm Godzilla. I'm going to tell you throughout the class that the equations you get, even before you get to the answer, will tell you something really important. And what this is telling you is $29,472 came from what? It came from multiplying 12% times the 245,000. So in other words, this is the maximum interest she could earn. And she earns it if she puts everything in at 12%. Now, why wouldn't she do this? Let's get all the money. And the answer is, well, that's a very risky investment. So she wants to balance it. She wants to diversify her portfolio. She wants to make sure that all of her eggs are not in one basket in case that basket, fails in the stock market, as they do. So this is the most she could make. And then you subtract. And what am I subtracting? Well, what I'm saying is for every dollar I put into X, where's X? X is the 5%. For every dollar I put in at 5%, I lose the chance of earning 12%. So I lose 7% for every dollar. So for every dollar, I lose 7 cents as I balance it out. But that's okay. She's comfortable with that because she wants to put some of her investment in here because it's safer. So just in case this totally blows up, she won't lose everything. She might lose a lot, and that would be sad, but she won't lose everything. So then let's solve this. Well, I'm going to subtract 29,472 from both sides. And I'm going to get negative 0.07x equals negative 9,472. This is how much extra she had, right? If she goes all in 12%, she gets an extra $9,472. Okay, so then what do? Well, I divide both sides, and I'm realizing I am rapidly running out of space. So I'm running out of time too. This is a long problem. Oh my goodness. Seriously, you guys should pause and get a snack break or something. Okay, so I've got, let me just copy this down. Negative 0.07x equals negative 9,472. Now, let me point out, a lot of people panic at this point and they're like, it's negative money, negative money. Yes, negative money, not always a good thing in business. However, both sides are negative, so we're okay. I'm going to divide both sides by 0.07, or actually negative 0.07. And then I need my calculator. So I've got 9,472 divided by 0.07. Now you may notice that on my calculator, I'm not bothering, let me get out of the light, I'm not bothering to do the negatives because I know that two negatives, top and bottom, make a plus. So I know that X is going to be a positive. What is it going to be a positive? It's going to be a positive. Oh my goodness, that's a lot of digits. 1353114.2857. This is, that's going to be a lot of rounding. So X is 135314. So $135,314. And then we look back at the original problem and we see it does not tell us how to round. Oh no. So this book frequently does not tell you how much to round. So there are a couple of options. When you take a test, I will tell you, round to the nearest dollar, round to the nearest cent. I'm going to go ahead and round to the nearest cent. And because we're working with dollars, remember that dollars are measured with 2 decimal places to the right of the decimal point. Different currencies have different standards, and ours is to 2 digits. So it's going to be 28, and then the next digit is a 5. When I look at the 5, 5 and above goes up. So we round it to 29. And then what I'm going to do is I'm going to change that equal sign to a wiggly equals. That means approximately. So if we come back here, did I answer the question? How much should she invest at each rate? Okay. No, I didn't answer the question because there are 2 rates. So 5% is X. Good. So she should invest $135,314.29. But how much should she invest at 12%? Okay. Well, the total was 245,600, right? And get it out of the light. I subtract 135,314.29 gives me 110,285.71. So $110,285.71. And now we're almost at 30 minutes, which makes this video absolutely too long. But let me say we can go through and we can check. 5% of $135,314.29 equals 0.05 times 135,314.29 equals 6,765.7145. And 12% of $110,285.71. 0.12 times 110,285.71 equals where is it? 13234.2852. Okay, so that's how much she would make. So she would make approximately, from the first investment, $6,765.71, plus from the second investment, $13,234.29. And if we add these together, 6,765.71 plus 13234.29 equals, it's all shiny so you can't tell, bam, equals $20,000 and a happy client. Yay! Woo! Guys, we did it. Okay, but we didn't do the whole thing. So I'm going to break this. We will have one more video from 1.1. There are just a couple of other word problems I want to go over just to make sure they all make sense. But you did it. You made it through the big video from 1.1. One more video, and then we can move on to 1.2 functions. Woohoo! Math on, guys. Math on.